Hey everyone, this is Jason Dinsmore from OrganicChemistOnCall.com. We're just going to follow up on the last video that we did where we first talked about how to use the periodic table and then figure out the number of bonds and the types of bonds. So I want to go into a little bit more detail from that of, well, what does that mean in terms of the bonds, because I didn't really speak about that, but just like we talked about before, if we look at carbon, and on the periodic table we've got 4, so that means that we can have 4 bonds to it, so we can take that and that would allow us to draw something like that since we've got all these single electrons. But how would this look if we were to actually, instead of just drawing the line, if we were to bring things together? So if we take a carbon atom, and we've noted that it's 4 in the periodic table, so we've got 4 spots. And then one atom we didn't talk about was H. So H is always only going to have 1 electron. So in terms of taking this, in order to take a carbon atom and a hydrogen, we would take our carbon plus 4 of those hydrogen atoms. Keep all that on there. And then all you do to make the bond is just match up the electrons. So if we take our hydrogen atom, we'd put one there, we put a hydrogen atom there, we put a hydrogen atom there, and we put a hydrogen atom there. So obviously every line that you see in a textbook is a bond, and it's really just 2 electrons. So if we were just to draw that, that obviously is equivalent. Oops, that should be an H. Of that. It doesn't have to be hydrogen. If we took carbon, I need that again. And let's say we decided to, let's just take another carbon. So if we took these together, same thing, we'll just do this a little simpler. If we took this and we brought that together, what that would allow us to do is a single bond, and then we would obviously have all these extra sites for bonds, so we would have 4 bonds. Now, this brings up an interesting point. So if we were just drawing something along these lines, we've seen systems where we can have carbon-carbon double bonds, and we've also seen where we can have carbon-carbon triple bonds. So if we take this one structure that we've drawn right here, and we bring these two up here, well, it seems like you'd say, well, okay, well, can't we just go, there's 1 bond, there's 2 bond, and there's 3 bond if we wanted to go all the way that way. If we went back, just look again, 2 bonds. We've got our 2 spots here for hydrogens, which we have here and here. Or if we do 3 bonds, we've got our spot out here and here for our hydrogen-hydrogen. For really all intensive purposes, yes, that is correct, because that's essentially what you're doing, is you just take the amount of electrons. So we would push that, whoops, that should actually be a half arrow. We would push that one down, we'd push that one down, we'd push that one down, and we'd push that one down. And if we were going to draw this more realistically or more accurately, we would try to put all of those 6 electrons in the same area, where then that would convert to a carbon-carbon triple bond. So that is correct. So with carbon, what's nice is when you just draw that, you can see all the different variants there. Alright, let's look at one other example. So, what if we had our carbon atom and we decided to take an oxygen atom? How could we put this together? So if we took these two, we could just do something simple where we just, like we did before, we just take 2 of these dots. So I'm going to flip this around, but it's essentially the same thing. So let's say I put my 2 electrons like this. And I didn't go over this, but I'm pretty sure all of you understand this, that it doesn't really matter where your pairs of electrons are. So in this case, I have a pair of electron there and there side by side, and then I have my single electron side by side. It doesn't matter, as long as for the oxygen atom, in this case, you have 2 sets of paired electrons and 2 single electrons. You can really do it any way you want. So if we were to draw it in this orientation, what would that give us? Obviously a single bond with a carbon-oxygen bond. However, that's not the only way. We know that, I'll just draw it up here, we can have a carbon-oxygen single bond, but we can also have a carbon-oxygen double bond. So if we were to take this system, how could we get a double bond? Well, the simplest way to do this is we would have to rearrange this once again, so I wouldn't draw it that way with the double bond. I would take this system, and we can keep that the same, so we know we're going to have a single bond, And all we have to do is just rearrange these electrons. So we're going to have one set of lone pairs there, one set of lone pairs there, and then we just bring one of those up there. And like we talked about before, to get it as accurate as possible, we're going to bring that electron down. We're going to bring that electron down. And then that's going to give us, and we'll leave them in the same spot, why not? So that's going to give us a double bond. I'll just draw the electrons. We don't need to get ahead of ourselves here. So now all 4 of our electrons in there, and if we just keep track of the other lone pairs, we have that and that. You can see that gets really messy. So we'll just slide that over there. And what would that look like? We would have our double bond here, our oxygen, and then typically you wind up putting each set of lone pairs on each side. And then we have 2 electrons, so if we wanted to, just to make this simple, we could wind up putting a hydrogen there and a hydrogen there, bringing those 2 together, and then we just do our line like that. So this is just, like I said, a follow-up to show you how you can use the periodic table to find how many number of bonds you can have to each atom, and then when you actually make a bond, all you're doing is bringing those specific sites that we talked about. Anytime you have a single electron on your atom, you can bring 2 of those single electrons together to form a bond, or if you have the possibility with some atoms, you can actually bring more of those single electrons down if you have the extra sites, in this case, to now make double or triple bonds.